Orbiting high above the surface of our planet lies a hidden world, a realm of energy and radiation that plays a crucial role in protecting life on Earth. These are the Van Allen radiation belts, named after the scientist James Van Allen, who discovered them in the late 1950s. Comprised of charged particles trapped by Earth's magnetic field, these belts serve as both a shield and a window into the mysteries of our space environment. But what exactly are these belts? How do they function? And what secrets do they hold about our planet and the universe beyond? To answer these questions, we must embark on a journey that explores the very fabric of our cosmic neighborhood, delving into the interplay of physics, the solar wind, and the magnetic forces that govern our existence. The story of the Van Allen radiation belts begins with the dawn of the space age. In 1958, the United States launched Explorer-1, its first successful satellite. As it soared into orbit, it transmitted data that revealed an astonishing discovery, a zone of intense radiation encircling the Earth. James Van Allen, the scientist behind the mission, played a pivotal role in interpreting this data, ultimately leading to the identification of two distinct radiation belts. This groundbreaking revelation not only advanced our understanding of Earth's magnetic environment, but also opened up new avenues for space exploration and research. It marked a turning point in our comprehension of the universe, inviting scientists to rethink their views on cosmic interactions and Earth's place within them. The Van Allen radiation belts are primarily formed by the interaction of Earth's magnetic field with charged particles from the Sun, known as solar wind. The solar wind is a constant stream of charged particles, primarily electrons and protons, emitted by the Sun, creating a dynamic interplay between our star and the Earth. When these high-energy particles collide with the magnetic field, they become trapped in two main belts: the inner belt, which extends from about 1,000 to 12,000 kilometers above the Earth's surface, and the outer belt, ranging from 13,000 to 58,000 kilometers. This dynamic interplay creates a protective barrier that shields the planet from harmful cosmic radiation, making it vital for sustaining life as we know it. These belts are not mere obstacles. They are intricate structures that reflect the complex relationships between celestial bodies, solar activity, and the Earth's magnetic field. The charged particles in the Van Allen belts predominantly consist of electrons and protons, which are accelerated to high energies by various processes. For instance, when solar flares erupt from the Sun, they release vast quantities of charged particles into space, some of which travel towards Earth. These processes include interactions with the Earth's magnetic field and the energy imparted by solar flares. As these particles spiral along the magnetic field lines, they become entrained in a delicate balance between forces, influenced by phenomena such as geomagnetic storms. These storms, caused by changes in solar wind, can enhance the radiation levels within the belts, creating a fluctuating environment that poses risks to satellites, astronauts, and even power grids on Earth. Understanding these fluctuations is crucial for predicting space weather and mitigating potential hazards, revealing the belts as dynamic entities rather than static barriers. For astronauts venturing beyond the protection of Earth's atmosphere, the Van Allen radiation belts present a significant challenge. The intensity of radiation within these belts can be daunting, especially during periods of heightened solar activity. During missions to the International Space Station and beyond, crews must navigate these belts carefully to minimize their exposure to radiation. Space agencies have developed strategies to mitigate risks, such as timing spacewalks during periods of low solar activity and utilizing advanced shielding materials in spacecraft design. This planning is essential for ensuring the safety and health of astronauts. as prolonged exposure to high levels of radiation can lead to serious health consequences, including increased cancer risk and damage to the central nervous system. The insights gained from studying the Van Allen belts are not only essential for current space missions, but also for future endeavors, including human exploration of Mars and beyond. With each mission, we learn more about how to protect human life in the hostile environment of space. To deepen our understanding of these enigmatic radiation belts, scientists launched the Van Allen probes in 2012. These twin spacecraft were designed to study the dynamics of the belts in unprecedented detail. Equipped with advanced instruments such as particle detectors and magnetometers, they have provided invaluable data about the structure, behavior, and variability of the belts. They reveal the complex interplay between solar activity and the Earth's magnetic environment, challenging our existing models of radiation dynamics and enhancing our predictive capabilities for space weather events. Each piece of data collected contributes to a larger puzzle, unraveling the intricate nature of our interactions with space and the influence of solar phenomena on Earth's atmosphere. As we analyze this data, we not only advance our scientific knowledge, but also pave the way for future technological innovations in space exploration. Among the significant discoveries made by the Van Allen probes is the identification of transient electron radiation belts that can form and dissipate within hours. These ephemeral belts, often referred to as Whistler mode waves, are influenced by solar storms and the Earth's magnetic field. They highlight the dynamic nature of our space environment and provide insights into how energy is transferred within the belts. Such findings emphasize the complexity of the radiation belts and their responsiveness to solar activity, reshaping our understanding of how cosmic events can impact life on Earth. For instance, studies have shown that these transient belts can lead to enhanced radiation exposure for satellites and even affect communication systems on Earth. As scientists continue to analyze the data, we gain insights not only into the belts themselves, but also into broader questions about the behavior of particles in space and the processes that govern the cosmos. As we set our sights on deeper space exploration, the mysteries of the Van Allen radiation belts will continue to play a crucial role in ensuring the safety of astronauts and the success of missions. Understanding how to navigate these zones of radiation is vital for future crewed missions to the Moon, Mars, and beyond. The challenges posed by the Van Allen belts require innovative solutions, whether through improved shielding techniques or enhanced monitoring of solar activity. Moreover, as we seek to establish a human presence on other celestial bodies, the knowledge gained from the Van Allen belts can inform our strategies for building safe habitats in challenging environments. For instance, research into radiation shielding could lead to the development of more resilient habitats on Mars or the Moon, safeguarding future generations of explorers. Future missions, such as the Artemis program aiming to return humans to the Moon, and the ambitious plans for Mars exploration, will rely heavily on the insights gleaned from our studies of the Van Allen radiation belts. Engineers and scientists must carefully consider the belt's radiation profiles when designing spacecraft and habitats, ensuring that technology not only withstands the rigors of space travel, but also effectively shields inhabitants from harmful radiation. This knowledge will be critical not only for the safety of astronauts, but also for the long-term viability of human settlement on other planets. As we step into this new era of exploration, the Van Allen belts stand as both a challenge and a beacon of knowledge, offering lessons from our past while guiding us towards an uncertain but thrilling future. The Van Allen radiation belts are a testament to the intricate interplay between Earth and the cosmos, a reminder of the challenges we face as we venture into the great unknown. These belts not only protect our planet from cosmic threats, but also serve as a key to unlocking the mysteries of our universe. As we continue to explore and understand the nature of these radiation zones, we gain not only insights into our own planet, but also into the broader tapestry of existence in the cosmos. Each new discovery adds a layer to our understanding, weaving together the threads of physics, biology, and exploration. What other secrets lie hidden in the depths of space, waiting to be discovered? Only time and exploration will reveal the answers, inviting us to question our understanding and explore the boundless wonders of the universe. The journey has just begun, and the cosmos awaits.